All right, this is the beginning of Chapter 6. This is the lecture for the Monday, March 8 and Monday, March 9. We're going to get partway through Section 6.1 in the book. We've finished Chapter 4. Skipping Chapter 5, skipping Chapter 7. We'll be doing Chapter 6 and 8. And that's pretty much it. We may have a little bit of Excel. In fact, I plan to have a little bit of Excel sprinkled in here and there. Okay, well, statistics is the title here, just an overview. It's not a full-on statistics class. But here's the plan for the chapter, and today we'll be just concentrating on data summary and presentation, boiling down the numbers. So yeah, raw data can be difficult to look at. To the trained eye, not so difficult, but if you haven't really dealt with it before, it may just look like a hodgepodge of numbers. So we're going to try to make some sense of it. Later on, in 6.2, as I get to this little bit of writing here, we'll talk about the bell curve, the normal distribution, the biggest part of statistics, because so many things are based on the bell curve. Not everything. There's 30 distributions I had to learn, but the bell curve is the biggest one. It's sort of the major distribution, takes up the majority of cases. And later we'll talk about the statistics of polling. This is not an election year exactly, but can we believe the polls? I gave the lecture right after Election Day 2016, right after all the polls were wrong, except for maybe one. And that was a very dramatic lecture. But we can talk about problems with the polls. They're not meant to be perfect. Best they can be is 95% accurate. Anyway, statistical inference in clinical trials, effective drugs, and that's also another timely lecture, because we have so much of the COVID and all the different vaccines, et cetera, So lots of stuff that we get to talk about in this class that don't make it into usual math classes. That these could be actually headline news type of things, but many other classes don't have that luxury. Okay, so let's talk about the basics, stuff you've undoubtedly seen before. I know because I've taught pre-algebra here, and when they used to teach pre-algebra here, and they taught this stuff there in the lower level class. So it may be a while since you've seen it, but the mean, very often called the average, because it's really by far the most used average, although there are several other averages really. You have a list of numbers, and it's the sum of the numbers divided by the number of entries, or the quantity in the list. So it's just basically the average. And very often that's the most important topic, but we do have others. And sometimes it's more important to look for the median. We'll discuss why later, but it would be the middle number. Assuming that the numbers have been put in order. You have to put the numbers in order, typically from lowest to highest, minimum to maximum. And when they're sorted in order, the middle number will be your median. But if there happens to be an even number of data points, then you'd have to take the average of the two middle numbers. Unless, of course, they're the same, then that would be your median by default. One that's also used is the mode. It's the most frequently occurring. So it's the most popular number. And sometimes there's more than one. If there are two such numbers, it would be called bimodal. And you could call it trimodal, multimodal if there's more than two numbers is a general word. We're not going to really use that word. We're not going to be talking about mode all that much, except kind of in passing. But it's stuff you've undoubtedly seen before. By the way, there are some data points such as 1, 2, 3, 4, 5, very simple data set, that don't have a frequently occurring number. They're all even. They all show up once. And especially when there's lots of decimals involved, it becomes rather hard to get duplicates. So then there is no mode at all. So sometimes data sets have no modes. I don't know if we'll see any of those. Okay, so here's an example. The Chelsea Football Club is a British soccer team. And the following table shows the goals scored by both teams put together in the games played in their 13-14 season. And the data are arranged according to the total number of goals scored in each game. So that's important to notice, because when you get to 7 goals, that's a lot for soccer. Soccer fans know this to be true. In fact, there are several games that have no score at all. And there are 5 of them. 0-0 ties, clearly, because there were total of 0 goals scored. Now, when you get to a championship or something, then they would go for a shootout. Even hockey's doing that. They go for kind of a shootout, and then there could be a winner. But this is just the total number of regular goals scored. And so it ranges between 0 and 7, and you can see there's around 50 or so games they played in a season. So they'd like us to find the mean, the median, and the mode for the number of goals scored per game. Okay, that can be done. Let's first start with the most important one, the mean. And to find the mean, we add the data values, that's the total number of goals scored, and divide by the number of data points, that's the number of games. They're going to say that in just a minute, so I'll just underline it there. So you got the total number of goals scored divided by the number of games. And so to find the total number of goals scored for each entry, in this particular case, because we don't have a full-on listing of all the games one at a time, we don't have like 50 listings here, 57 listings. They've tabled it, so it's more convenient. But then to unravel that, we have to figure out what the total number of goals scored. So for every column, for every entry, you multiply the goals scored in that column by the corresponding number of games. So let's take a look back here. In other words, 0 goals scored times 5, of course, that's 0. 1 goal for 10 games, 1 times 10 is 10. 2 goals apiece for 14 games, 28. They're going to show you the details here as you look on this page here. 5 times 0, 10 times 1, 14 times 2, and then 14 times 3, and then 10 games had 4 goals, 2 games had 5 goals, and then only 1 game had 6 goals, and only 1 game had 7 goals, a total of 143 goals. And then the number of data points, so the total number of games, you just add them up from the most popular to the least popular. Basically, you start with 5, 14, so that's going to be a number we see in just a minute, for a total of 57 games. So now that we have those two numbers, we can just divide them and find out what the mean would be. So the mean, the total number of goals scored, divided by the number of games played, 143 divided by 57, gives us a number. It's not exactly 2.5, but it rounds to 2.5. And then the median. This one we're not going to really hold you responsible for, not with big groups like this. But let's go ahead and go through it anyway so you have an idea of what we're talking about. And we'll talk about the median in a better example coming up. The total number of games is 57. That's odd. So what you do is you kind of take half of the 57. 57 divided by 2 is 28.5. It turns out you have to round up to get to the 29th lowest, which happens to be the 29th highest low-score game, because that is the middle number in a ranking between 1 and 57. And, by the way, the gold numbers would be 0 up to 7, but let's not worry about that right now. Somewhere in the middle is the 29th value. And no, we're not going to break out a formula. No, we're not going to have you really do this. I can't swear about homework problems, though. I don't think I put one of these in. I'm pretty sure I avoid these because it just causes more problems than it helps. And I don't think it's all that important for table data to worry about the median. But the mean is actually pretty easy, though. Well, anyway, this number happens to be 2. Now, how would we know that? They're not being especially clear here. But let's kind of go consecutively. The number of games is 5 at the end of the 0 goals scoring column. But then when you get to 0 or 1, that's a cumulative total of 15. I've been using this a lot in my other class. And then, because 5 plus 10 is 15, you go to the second, or the 2 goals scored, the third column actually, 15 plus 14, there's your 29. This is the first time I've actually gone through this much detail on this explanation. But the 29th value is just barely a 2. But notice the 30th value would cross over into the third realm, and it would be between the 30th and, say, 43rd value. And over here is the 57th value over here. Well, we're not going to worry about that, 56, 57. But the median is right there. So don't, as I say, if you didn't follow all this, don't panic. We're not going to really have occasion to use it. I'm much more worried about the mean in a case like this. So let's get back here. And yeah, the median is just barely 2, but just barely. And that reinforces the 2.5. It just about crossed the line over into the 3 zone. Now the mode. we recall that 14 times apiece, as I go back to the regular data, we had 2 goals 14 times and 3 goals 14 times. This is what we call bimodal because they share the lead, so to speak. And so we have 2 modes, bimodal. Don't average them. It's tempting because the mean seems to have done that. But no, don't do that. The modes are 2 and 3. In fact, the modes could have been 0 and 7, but that would not have been a soccer situation. But in other data sets, maybe it would have been. Well, anyway, on average, the teams combined to score 2.5 goals per game. Half of the games had goals totaling more than 2. The most common number of goals were 2 and 3. So right around 2, 3, 2.5, all those seem to reinforce each other. There are data sets, though, where there's wide differences. We'll even see a little bit of that coming up. When the mean and the median are the same, that's an indication that you may have a bell curve. When they're far apart, then it's a sure indication you do not have a bell curve. And that's where the median starts to become more prominent, when it starts to depart from the mean. Because if they reinforce each other, there's no guarantee, but it's pretty likely you're going to have a bell curve situation, which is the most typical situation of all. Things are just settling into the same. And this looks like a sort of a bell curve scenario. But there are others that we'll see pretty soon that don't fit that mold, especially when it comes to income data or housing data, various economic data that the government collects, that real estate agents even collect, and they know that you just can't go for the average house because there's such a disparity in housing prices. Okay, so let's go to this next one. And speaking of which, the following list gives home prices in thousands of dollars, although it's been a long time since I've seen a house go for $80,000. Well, of course, this is about 6, 7, 8 years old, so that's part of it. And it could be they're not talking about California. It could be they're talking about, I don't know, West Virginia, Montana, someplace like that perhaps the housing prices aren't quite so high as they would be here. I don't know why that did that. Okay, so anyway, the list includes the price of one luxury home. That one kind of stands out. Later on, we'll see if that could be called an outlier. But the 80, the 120, 125, all the way up to $190,000, and we just isolate the thousand so we don't have to drag all these zeros around. That's just not fun. The 820 tends to really stand out as 4 times, more than 4 times its neighbor, the 190. But we'd like to calculate the mean anyway, and then the median, which of the two is more appropriate for describing the housing market. I've already given you a clue for that. Well, when you find the mean, you add up all the numbers, and you get $1,655,000. There are 7 on the list, easy to add up and find 7. When you divide by 7, it rounds to $236,400. You could say it that way if you want. No need to go any deeper than that. We don't need the nearest penny here. I know in Money Calculations in Chapter 4 we were doing that. But for here, you could do it, but there's no need for that. So this would be called the average price of a home. But there's a problem with that. $236,000 is bigger than almost all of the values. In fact, it is bigger than everything except for the 820. It lands at the edge of the data. That doesn't sound too good to most people. This list of 7 prices, of course, it's arranged in order. It has to be in order for us to even consider taking the median and later on quartiles. So the median will be the 4th value. Well, why is that? 7 divided by 2 is 3.5. And yes, you round that up to 4. Typical roundup situation. Another way to do it, if you just have a small amount of data, is just to kind of go in from the sides. I know I've got one professor hates it when I do this. She just makes her angry. But I find it very simple. And you go in 3 from the left, 3 from the right, and what's left is 140. Or if you want to try to use a formula, divide by 2 and round, and then you go to the 4th value. And either way, you get $140,000. Now that one does seem to be more representative of a typical house, which is what averages are supposed to try to do. So the mean is higher than the cost of every home in the market except for the luxury home. Maybe Bill Gates's home or somebody like that, The median of $140,000, however, is more representative of the market. And here we see a big gap, nearly a $100,000 gap between these two numbers. Wow, that's not what we call bell-shaped or standard normal, or however you want to phrase it. So yeah, 140 seems to be a better number. So real estate is notoriously median-centered. It's very rare for real estate data to actually turn out to have a mean and the median be anywhere near each other. That would be extraordinary if that ever happened. I'm not saying it would never happen. It just would be extremely rare. And so we have some definitions to talk about. Here we have the idea of an outlier. It's a data point that is significantly different, not just a little bit different, but significantly different from most of the data. And as we saw back here, this 820 certainly fits the bill, being 4 times as large as its neighbor 190. That would be called an outlier. Now, in other classes, we do have outlier tests, but no, we're not going to worry about that here. Because sometimes you get to numbers that maybe, oh, I don't know, what if we had 290 instead of 190? Is that an outlier? Maybe. And what about 240,000? I'd say no, that's not an outlier compared to the 190. 240 just isn't that much bigger. 290, now you're starting to get into a gray area. 300,000, that's a gray area, and there's a formula for that. We're not going to worry about that because it needs standard deviation, stuff that we'll be talking about, but we don't have time to talk about every little thing here. This is not a full-on stats class. This is only just one chapter, and we'll just hit the highlights, some of the more useful things for you. Okay, so I'm going to go to the second quartile first. It's the same as the median. So we've already gotten the median, and we've also gotten the second quartile. Sometimes people even call it Q2. And I would allow you to say Q2 if you'd like. That's just a faster way. There are other symbols. Every book seems to have its own symbol for median. You could say MED. M wouldn't be very clear, though. M might mean mean. It might mean mode. There's other problems with the letter M. But if you want to say MED or Q2, that would be fine. But let's get back to first quartile. First quartile of a list of numbers, of course, sorted numbers. They've got to be in order. It's the median of the first half in the data, the lower half of the data. So it's like the mini median, the way I look at it. And we'll show you how that works. I got to get my pen on again. So I'll put the prefix mini median in front there. And it's of the first half. Let's call it the lower half if you like. I'll just say the first half of the numbers. And then the third quartile, very similar to that, it's the median of the upper half, or the second half of the data. So what happens is we divide the data up into quarters. Now, we have to let you know that different software gives different answers. So we're going to expect you to do this by hand. So if I catch you using software, it's going to stand out. And I'm going to say, hey, you got the wrong answer because so-and-so company does it differently. And we're not teaching it that way. They just never really got on the same page on this. I think it's kind of weird. It reminds me of, if I've been talking about PEMDAS, and I might even have given you the story about, a couple, 150 years ago. They hadn't figured it out, especially in certain countries. And, that caused problems because it does matter if parentheses go first or exponents go second, things like that. And so here they hadn't even figured out what to do with that. Now, that's just something I find intolerable. It's just embarrassing. It's kind of one of the first things we've even mentioned in statistics, and they can't even get on the same page with it. That's just crazy. And there may be others that are much more advanced that very few people would know about. But at that point, because this is an exclusive club that knows about this stuff compared to everything else, then they would have handled it. They would have gotten that taken care of. But here, it's just one of those things. Well, anyway, we have this thing called a 5-number summary of a list of numbers, and it consists of these things. You've got the min, the smallest number of all. That's the very first number seen. And of course, these numbers have to be put in order. If they're not put in order, it's just garbage in, garbage out. And I've seen many people take numbers that are written out of order on purpose. They forgot to put it in order, and they start getting all this stuff, and all the numbers make no sense at all. They're all screwed up. Well, anyway, the minimum, the first quartile, the median, or the second quartile, same thing. Third quartile, and then, of course, the max. So that's basically the 5 numbers. And when you put them in that order, then lots of people know what you're talking about. In fact, they may not even need to see a picture of it. They already kind of know what's going on just based on those 5 numbers. Yeah, that's how powerful they can be. Now, frequently, we're going to be doing more with that, including today. We're not going to just stop there, but it is possible to stop there, I suppose. So what we'll have to do is look at the data set, and we'll take a close look at that. But maybe we'll come back and do that one later. Let's just take a look at this example here. Every year, Forbes magazine, famous magazine, publishes a list it calls the Celebrity 100. So the table, this goes back 10, 12 years, but it shows the top 9 names on the list for 2009, ordered according to the ranking of Forbes. But it also gives the incomes of celebrities that were updated from the 12-13 fiscal year, so a few years later. But we'd like to get the 5-number summary for this list of incomes. Okay, so you've heard of most of these people, I'm sure, because they're still mostly pretty big stars. Oprah, Lady Gaga, Steven Spielberg, Beyonce, Madonna, Taylor Swift, Bon Jovi, Roger Federer, famous tennis star, Justin Bieber, etc., etc. So you've got all these incomes, but notice they're not put in order. In fact, there was no real order at all. It wasn't even alphabetical. So, but notice, hey, this income's in millions, rounded to the nearest millions. Must be nice. But anyway, we're not going to need to drag all those digits out, and cents and everything else. We just don't want to do that. So what they're going to first do, step 1, if it isn't already in order, and it might be, but it might not be, put it in order. So we arrange the incomes in order, and basically that's what we have to do. So just seeing if there's any obvious mistakes. I don't see any. 53. So Beyonce at this point was not earning so much money. That changed. So 53 million, going all the way up to 125. By the way, that was Madonna. She's taken a tumble. She's, I guess, semi-retired now for all I know. But anyway, that's the way it was back then. Lower half of the list consists of the 4 numbers less than the median. First of all, let's find the median. So if you want, you just go in 4 notches on the left and 4 notches on the right and find the 77 that's in the middle. So just trying to draw them on the screen. Or if you want, you can just take the 9 values, divide by 2. I haven't really taught it this way in a while. And you get 4.5, round that to the 5th position. No matter what the number is in order, for 77 would be the median. And this one doesn't really look too bell-shaped because the 125 does stand out a lot from the 100, and so that may be considered an outlier. It doesn't look very symmetrical in any way. So anyway, the lower half of the list, they call it half. That's a generous wording. It's not really half. Lower 4/9, you could say, consists of the 4 numbers less than the median, and there they are. Now we're going to take a mini median of this, and halfway down the line, you could even say 4 divided by 2, is a number, well, it doesn't even seem to be there, because we have an even number in our data set now, our mini data set. So we have to average 55 plus 58. So it's the first time we've seen an example like this, but undoubtedly you've seen this before somewhere. And then we get 56.5. Do not be discouraged by the decimal place. Sometimes you have clearly integer data, like number of pets people own or whatever, and then you have a 0.5. People say, oh, what's that? Well, no, don't worry about it. That's just a number. In fact, we've talked about this before. So the first quartile, I don't know why that does that, is 56.5 million. Now, the upper half, upper 4/9, notice the median is excluded. In the method that we will use, we will exclude the median. So let me make a big deal of this. They're not making a big deal of it because certain packages include the median, including the book I'm teaching out of for 2265. Do not include the median. That's a very big thing here. Now, if there was no median in the first place, and you had to invent it in the beginning, okay, nothing to do. Nothing to see here. But a lot of the time you get odd number data to find the median, then you throw it away. Do not use it. That's a big way to make a mistake because we're only going to accept this method. I don't even know what company it is. I don't want to point any fingers, but another company might disagree, but I'm going to disagree with them and pull rank on them and say this is the way that almost everybody does it just because one company doesn't see fit to do it that way. Well, whatever. Okay, so comes the upper half, and we find another even set, so halfway down the line of the 4 numbers, and I'll once again use half loosely. It's not really a half, and I've had lots of people point that out and say they got it wrong because they didn't see a half in there. And okay, this is not really a half, it's the lower portion, an upper portion. But this is an easy one, 80 plus 100, and of course divide by 2. Equals 90, and I forgot to say that as well, so there we go. Up there, we divided by 2. I didn't make that very clear. I apologize for that. So now we have 5 numbers. We've got the 90 as the upper, well, the mini median of the upper half, the second set of numbers. So I call it a mini median. And so we have our 5 numbers. They'll show up on the next slide. The minimum, 53 million. Everything's millions. First quartile, pretty close to that, 56.5. And median, 77. Third quartile, 90. And the maximum, 125. It starts to kind of have a bigger gap there. And incidentally, you could think of this as a football game or a pro basketball game with quarters, or any other sport that has quarters. So the minimum would be the beginning of the game. First quartile is the end of the first quarter. Median is halftime. And the third quartile is the end of the third quarter, starting the fourth. And then the maximum is the end of the game. And let's assume no overtimes. So that's just an analogy that might help you envision what's going on here. So there's just major points of a game, the beginning, the end, and all the points in between. And we're not talking about, college basketball with halves or hockey with 3 periods or any other sport that does it differently. So here is what we call a box plot. This is a nice, handy picture that we can use to represent the data. And by the way, they're not cookie cutter box plots. I'll make a big deal of that coming up. So anyway, the pictorial display of the 5-number summary called the box plot, or sometimes box and whisker plot. You can see it that way too. The basic geometric figures used in a box plot. This is the horizontal type of method. Vertical type of method. I also prefer the other method, which I'll show in just a second. But we see quite clearly at the top is the maximum, and then the third quarter, the median, first quartile, and the minimum. Notice between the first and third quartile is where the box is. So there's kind of a box here. And the line, which may not be right down the middle, in fact, it almost never is. This is an idealized situation. Don't take this to heart. This is meant to be just a general shape. You could easily have something that, has a wide box with the line way up here, then maybe a very long whisker at the end. So here's another example. So I've got to give it equal time, because this is much more typical on the left than you'll see on the right. And yes, so you do need a scale. Without a scale, it is worthless. I have to make a big deal of this because I've seen probably over the years 20% of students don't put a scale down. And then I've got nothing to grade. 0 points for you because you didn't follow the rules. It's like not putting the data in order. If you don't have a scale down, I just don't know what you're talking about. Everybody here has done some graphs. We're not doing a lot of graphs here. But yet, without a scale, you just don't know what you're talking about. So you have to put something down, such as, 0, 50, 100. Anything will be better than nothing. And you could put a few more numbers in. Pick like what's in your wallet, 10s, 20s, 25 cents, stuff like that, stuff that's regular, and just count by that and then see where the data lands. This is not a cookie cutter situation. I have to say that over and over because I'll get some people that barely watch the lectures, which is very sad in my opinion, and just do it their own way, and then they're shocked that they don't get any points. Oh well, I tried to tell you. So you've got to put a scale down, then see what happens to your box plot, because every box plot is different. Cookie cutters say that every person is exactly the same. Of course, that's crazy talk. So you don't have that. Everybody's an individual. Every box plot's an individual too. Now, I don't want to put humanity into a box plot. That's not my point. But yes, there are differences here. If you don't even take a look at the differences, you've really missed the point completely. So there's so many things that could be done with a box plot. And oh, by the way, we do have the horizontal method, which is the way I learned it, which I do kind of prefer, but we will take either one. So let me see if I can kind of show you something similar here. Going from left to right, and we have our box, and maybe the box goes over this way, and maybe the line is way over to the side, and maybe we have a real tiny whisker over here on the right side. So here's another example that's going from left to right. Many books do it this way. But I will say in recent times, and I've taught out of so many books, the recent times seem to be going towards the vertical method, which I do not prefer, but hey, it still makes sense. Be sure the maximum's on the top, of course, and left, right, the maximum would be on the right. So let's take a look at various things, and let's find the 5-number summary for city. Well, why don't we go ahead and, as we had the data set, let's go ahead and take a look at this slide 7 where we had the home prices data. And maybe we can come up with a 5-number summary for this. Okay, well, we found the median. So if we're going to do that, the median was 140. The median is excluded. So seal it off. Take a look at the first part of the data. And there is one number that's in the middle of those three. That means that Q1, first quartile, it's a nice abbreviation, is equal to 120. Similarly, you go to the upper half of the data, the second part of the data, half, used generously, and 190 would be your third quartile. Now let's not forget the max and the min, which is just like free points for you if you know what to do. The minimum is 80, and the maximum is 820. Now I don't think I have room here, and I didn't jot these numbers down, but 80, 120, let me, well, anyway. Let me see if I can cram it into this data set. And I'll go left to right, and I'll put a scale down, 0, and then notice the max is 820, so maybe I'll just have to say something like, oh, I don't know, 1,000. Some number that covers your 820. I suppose you could use 800 and go a little bit further than that. That would be okay, but 1,000 is the number I picked first. So let's just try it this way, 0. I'll cut that in half, go to 250, and go the average between 500 and 1,000, 750. And by the way, if you don't have a perfectly straight scale, I will not worry too much about that as long as you give it a good faith attempt. That's all I'm really worried about. So the minimum is 880, and on the scale, it's only about a third of the way over between 0 and 250. So that's where our first little notch would start. And we go up to the 120, which is not a movement much at all. It's like to the halfway mark where the box would start, where Q1 begins. They're mostly focused on the area between Q1 and Q3. That's a very important area. And then the media is just barely over from that, 140. Then our Q3 is 190, and that just barely moves the needle over here just a little bit. So our box is kind of compressed. And now notice what happens to the max. The max would be a little past the 750. So now we have a very long right whisker, as they say. This indicates skewness and other things. So this is not a cookie cutter box plot, not even close. So for people to pretend as if we don't need a scale and every box plot looks the same, I find it offensive, actually, and I'm happy to give 0 points. And I rarely say that, but that's one case where I am actually happy because I make a big deal of this and some people just aren't listening. But not you, because you're clearly listening to me. Thank you very much. So we go back and take a look at the general box plot. Now we're going to go to another example, and a report on greenercars.org shows the 2014 model cars with the best miles per gallon fuel economy. And they'd like us to find the 5-number summary for the city mileage, and there's a box plot you could get for the city mileage, and they have a comment of how the data is distributed. So here's the data. Notice they wanted to focus on city mileage. They've given us extra work here. That could also be done as well. Maybe we'll have a chance to do that. So anyway, these numbers have already been sorted in order, which is nice. The best one that year was the Toyota Prius C, 53 miles a gallon city. And, you know, Priuses tend to get better mileage in the city. I always found that weird. My mom has one of these types of cars, and she gets better mileage driving around town than she does on the freeway, which is so backwards from the way I'm used to seeing it. Now, the Honda Civic Natural Gas didn't do so well, only 27. That's about half, and all the numbers in between. Okay, so then they take the numbers and they put them in order. There might be, anyway, they put them in order, and let's see, you got 27, 34, 37, 41, 42, 44, 51, 51, 53. So yes, we do have all those values. It looks like there are 10 of them. And so they put the 42 in boldface. They should have also put the 44 in boldface because these are the two middle numbers. Right down the middle, 10 values, divide by 2, of course, is 5. So you go between the 5th and 6th value. There's a big old flow chart I'd rather not get into, but just intuitively, go in 5 from the left, 5 from the right. You're right down the middle, 42 plus 44. And that's a very easy one to average. They're off by 2. There's a difference in 2. And so just make it move 1 unit. And so you would get 43 miles a gallon for the median. So the lower half of the list, and here's a case where we actually do use the half. So when we have an even number, glad we did one of these, then we really do have a half. So I'm going to just draw the line right down the middle. And we have split the data up into two halves. They really are halves. And they forgot a number here. They forgot to put the 41 in here. Too many glitches in these. The glitches mostly remained in the third edition, and they're not nearly as colorful. Anyway, the median of this half is 37. Now, the mini median, Q1, is, well, let's just take a look. Let's not trust them. Let's do it ourselves. So we go in, a couple notches to the left, a couple notches from the right, and the 37 reveals itself as the Q1 right down the middle. Okay, now let's take a look at the third quartile. And we take a look at the upper half, and they actually listed all 5 of them this time. And although we have a kind of a triplication, clearly the mode here is 51. There are 3 of them. Notice the mode doesn't have too much to do with this. But we go into the middle, like we did before, the second half of the data, we get a 51. There's a lot of duplication there. So the third quartile is 51. That's Q3. So now we're armed with all the information that we need. Now let's list them. The minimum is 27. The Q1 is 37. The median was figured out to be 43, even though it's not officially on the list. So we don't officially exclude it because we had to invent it. So we do get to cut the data in half if it's an even number. That does make a difference in the calculations of your Q1s and Q3s, so just so you know. Then 51 is the Q3, and the max is only a 53. They're relatively close together over there. If there's a gap, it's over on the left end for a change. So using those numbers, and by the way, let's make sure we're clear on this. The 5 numbers are assumed to be in this order. The minimum, Q1, the median, I'll just say MED, you could say Q2 if you want, and then Q3, and then of course the max. So that's what has to be for 5-number summary. So that's what I've done, 5-number summary. My handwriting isn't very good writing at an angle here, but here's what the picture looks like. Now I don't have those numbers handy, but yeah, I do. This is a 27. Now you don't have to put the numbers on the picture. In fact, they usually don't, but I'm going to go ahead and do that to illustrate stuff. And by the way, they've taken the opportunity to color code this too. They didn't have to do that. But 27 is the minimum number. Then we had a 37, big jump there to get to the first quartile, where the first quarter of the data is bordered by. And then we have a 43 for the median, and 51 for Q3, and then just a little bit off the scale is the maximum. And that's okay. You don't have to put a 60 down or a 55 down. But notice they started with a number that covered the 27. They went all the way down to 20. And they counted by 5s. A very typical way to go. And oh, by the way, if you happen to count by 17s or 11s or 13s or something weird, at least you have a scale. No points will be deducted. I'll just frown a little bit and say, who would really want to look at this? But at least you didn't do anything wrong. And here's the thing. A lot of computer programs do that automatically. They count by 11.72s, which is just, I find to be very distracting. Very distracting. But hey, I'm just used to organized data. What can I say? And at least it's not unorganized. It just could have been improved a little bit. No penalty would be given. But of course, what I get a lot of people doing is they'll say, okay, here's 0, here's 10, here's 11, here's 121, and then here's 1,987. And they think that's a scale. No, it's not. That's maybe a logarithmic scale, which we didn't even talk about. That's just garbage. You may as well have skipped the scale altogether if you're going to put down garbage numbers like that. And sometimes they put them out of order, too. That's even more fun. That just shows a total lack of attention to detail. And it's graded that way, of course. So if you want credit for your box plot, give me a scale for starters, please. That would be quite important. Now, how do you do it? Well, it's more of an art than a science. You look at the middle number, the minimum and the maximum, and those kind of frame your scale, in case you haven't done this in a long time. And you could start with 27, I guess, and count by 3s. That would be a little weird, but you could do that. But maybe just back up to the nearest round number. A 25 or a 20 would be perfect. Counting by 1s, 5s, 10s, stuff that makes sense. Even 2s could be used. Even 1s in rare cases could be used, but hardly ever are. And then you could max it out at 55 or 60. They chose to max it out at 50, provided your max isn't too much higher than your highest number on the scale. You should be okay. we're not going to worry about it. But if the maximum number was 70 something and you stopped at 50, that would be kind of weird. That would be a small mistake. Actually, a mistake in my opinion. But anyway, we see all kinds of stuff with the box plot, and things that they look at are the relative lengths of the whiskers. This is a rather long left whisker here, down here. Well, bottom whisker, I guess you could say, and a very short upper whisker, or right whisker, as they often say. So this is supposed to be a 53. And okay, they even listed all the cars. This is very unusual. Almost never happens. They listed the cars and their gas mileages rounded to the nearest whole number. And we kind of see it. The box, however, looks like it's just about symmetric. Now, I do notice that it's not symmetric and that the gap between the 43 and the 37 is 6, and the gap between 51 and 43 is 8. So it's really like 8 there and 6 there. So it's a bit of a distortion, I think, on the drawing. I think this yellow line got moved up a little bit too high. Maybe it was 43.5 or something like that, 43.44. I don't know what it is. But anyway, we do have a little bit of it's not as symmetric as it looks, so a small mistake on the graph. But that type of thing I would not really hold you to. I just want you to do the best you can, list the numbers, list the shape, and then do the best you can to size it up. In the absence of using graph paper, it'd be about the best you could do. Okay, so finishing this off here, referring to the box plot, we notice the maximum is not far above the third quartile. Yeah, that's what they're saying here. 51 to 53 has a gap of only 2, whereas the gap at the bottom, 37 to 27, a gap of 10. These numbers I'm just putting for illustrative purposes. They're not really necessary, but they do tend to explain things a little bit better, I think. The top 4 cars in terms of city mileage are not far apart. Going back to the data, look at the top 4, practically a 4-way tie. Yeah, that's, that's a lot there, all crammed together at the top. But at the lower end, the minimum of 27 for the Honda Civic using natural gas is there's a big difference between its neighbor. In fact, you'd almost have to say that's an outlier. I'm almost certain that would be an outlier, off by 10 from its nearest neighbor, which was the Mercedes-Benz Smart for 2 convertible coupe. Okay, never heard of that one. Okay, anyway, there's a bigger gap there. So yeah, that might be even considered an outlier. But they're not really worried about outliers. We're not going to be really doing anything official with that at all. It's just meant to be a general term that we can throw around when it looks kind of clear, kind of obviously meant to be an outlier. So that's kind of how that goes. And so I could go through the data for the highway mileage, but I think I'll go ahead and postpone that. I think we've probably gone long enough today, but here you start with the 38. This data is not sorted, so there'd be a little extra work involved. And well, come to think of it, let's go ahead and take a look at it. With the highway mileage, which was not requested, as I sort this in order, 38, 38. It's almost in order, but not quite. Notice these don't line up perfectly well. And the 44s do line up. And then we have a 47, actually a 46. That one came down quite a bit. It's actually in the first half of the data now. And then 47. And then 3 48s and a 49. Put a comma in there. So now let's see if we can get the 5-number summary at least. Halfway down the middle, dividing up 5 on the left, 5 on the right. Halfway, that's pretty easy. It's 46 and a half. Just add the 2 numbers, divide by 2. Also move just half a unit over. That would be, I'll just call it Q2 to be different. Now let's go find Q1, the middle part of the first half of the data, the third value right in the center. There it is, 44. That would be called Q1. And let's not forget the minimum. The minimum's very easy. There was a tie there, but that's okay. That's the min. I'll move over to the second half of the data now, and the third value out of 5. Once again, kind of a triplication we saw before. But that would be Q3, and then a max, of course, be 49. So we have our 5-number summary, which I'll list over here. 38 is the first minimum number. Then Q1, 44. Q2, median, 46.5. Median sometimes will have those extra 0.5s in there. It just happens. 48 for Q3, and then a very tiny gap of 49. So now I'm going to try to do a box plot, and I'll have a different scale than before. This is a little bit more condensed than the other data, so I could change the scale. Now, if you're going to put them side by side, that may not be a smart move. But well, maybe I should try to do it side by side. Let's see if we can do that. We've already got a scale here. So 38, it would start right about here. So now this box plot for the city mileage is already much higher than the other one on the left. So this is part of the reason box plots are done. So I shouldn't miss the opportunity to compare box plots side by side. So that's your 38. And then let's take a look at some of the other data we just got for the highway mileage is what we're looking at right now. 44 and then 46.5. So let's see if we can place them here. 44 is just a little bit up from the 43, almost at that line. So 44. And 46.5 is just a slight amount above that, 46.5. And then let's see, we have the next number, if I remember right, there it is, it's 48 and then a 49. So this is moving very slowly. It's very condensed. So 48, if I can scribble this in, you got your 48 and your 49. And so let's see if I can piece together the box plot. I made the lines a little bit too long perhaps, but anyway, that long lower whisker goes there. The box contains the Q1, Q2, and Q3. Then the little tiny whisker at the end with only one unit in between does show a box plot. And this one is a lot more compact, more consistent. And this gets into things like standard deviation, like what's in the box. What's in the box here is not too much. 48 minus 44, only 4 units in the box. 4 in the box. Where over here, inside the box, 51 minus 37, there was 14 in the box. Much wider distribution. In fact, one number was double the other. So, wow, that's quite a difference there. Whereas when you get to the highway mileage, much more consistent, less of a deviation, as they say. Okay, so I couldn't resist the opportunity to show you another one. And feel free to work on others because I'd say it's very likely you'll be seeing this again on one test or another. And so be sure to master this kind of concept. So next time, when we come back live on Wednesday or Thursday, depending on which sections you're in, we have 4 of them, then we'll continue with 6.1, maybe get our foot in the door of 6.2, stuff like that. And by then, I'm hoping the tests will be just about ready. So I've got some work to do this weekend on that. So meanwhile, stay dry. I hear it's supposed to be raining soon, so stay safe, and we'll talk to you later. Bye-bye.